on LeetCode problem 1157, online majority element in subarray. This question is a hard problem, and if you didn't see a similar problem before, it will be quite hard. But once you see one or two questions of the similar form, it will not be very hard because the implementation is relatively simple. Just the idea is pretty new. So let's see what this question is about. So this question asks us to design a data structure that efficiently finds the majority element of a given subarray. And this array has a length on the order of 2 times 10 to the fourth. And each element will be on this level. Then it is guaranteed that the threshold we want to find between the left and the right will be the majority element. So 2 times threshold will guaranteed to be larger than the length of this subarray. So if we do that naively, we will have a time over the time limit, because the length is 2 times 10 to the fourth. And if we just search for the threshold, it'll be very long time, 10 to the eighth. So what can we do? So the idea here is to divide the situation into two major subproblems based on the threshold. So based on the threshold, we choose different algorithms to calculate. And if less than the threshold, so if the threshold is less than some value, we call that th, less or equal to some value, then we just do a search naively, right? Then if the threshold is greater than some value, then we will use some pre-computed sum, use pre-sum to calculate. Then how many numbers should we calculate for pre-sum? Suppose we have n numbers, so numbers we need pre-sum is just equal to the total element in this array divided by the threshold, right? Because if each number have a threshold greater than th, so it means the count of that number is greater than th, then at most we have this number of elements. So we just need to record a small portion of the elements for situation 2. Then the problem is how to decide th. For example, if the th is very large, then situation 1 will take a very long time, right? And we decrease th, and every time we decrease th, situation 1 calculation time will be decreased, but situation 2's time will be increased. So to balance those two, we let situation 1 and situation 2 have the equal time. So for situation 1, the time complexity is on the order of th. And for situation 2, the time complexity is inversely equals to th. Then if we make K1, we make those two equal. So we suppose they're equal. It means with some coefficient, they will be equal, right? Then this will give us th should be on the order of square root of array size. Then to simplify, we just choose th on the order equals to the square root of array size. Then this algorithm will be also on the order of square root of array size. Because array size is 2 times 10 to the fourth. 2 times 10 to the fourth. What is the square root of this number? It is around something 1.4 times 100, right? And how many elements we have? How many queries we have? So we have 10 to the fourth query. Then if we times 10 to the fourth, then this will be on the level of 10 to the sixth, right? This will guarantee we can solve this problem in a reasonable time. So let's implement it. The implementation will not be very hard. So the first step is to define th, right? So we have a th, and we say th is equal to square root of array size. Then for situation 1, we don't need to do anything. We just need to prepare for situation 2 in the constructor function. So we will need to first use an order map to get the count of every element in this array. Okay, then for each element in this hash, if the count is greater than th, then we will need to do something here. We will just pre-compute its pre-sum. So because we will use it later, we define it as the private variable. An ordered map int is a variable, and we have a vector is the pre-sum. We call that h. So this is variable, or we'll just call that number to pre-sum of number in for count. Okay, then we actually need to access this array in the other function, so we just make a copy here. And then we say array will be equal to array. Then we can calculate the pre-sum. So we for I equals 0 until array size. If I is 0, what shall we do? If array at this position is equal to x, then hx should push back 1, right? Otherwise, hx just push back 0. And for other positions, if array I equals to x, hx push back 1 plus hs x back. And otherwise, we will push back the previous number in the hs array. Okay. I think we are done for the constructor. We can actually do some print to check if we implement it correctly. So in order to do that, we need to print out all the key values in H. We print K, then for each value in V, we print out that value as well, and we print out the TH as well. Okay? Let's first check whether this is correctly. We just return 0 here. And so we have 1, 2, 3, 4, 5, 6, and square root of 6 is 2, so this is correct. And for the element larger than 2, we only have 1, right? So 1 is larger, the count for 1 is larger than 2. And the pre-sum for this count is 1 and 2, 2, 2, because there's no 1 here. Then increase 1, we get 3. The last one is 4. Okay, this seems also correct. So for the constructor part, I think we are done. Then we come to the query. So there are two situations. If the threshold here is less or equal to TH, we just naively search. So for I equals to left, I less equal to right, we use the ordered map to record the count. So count array I plus plus, right? Increase. And when we have a number, if this one equal to threshold, we know we found that value, because it is guaranteed that we have, if we can find one, it is the only one we can return. So we just return array I. If we do not find anything, we return -1. Okay, and for the second situation, for this situation, we use the pre-sum to get the count, right? So for the key and value in H, and remember V is the pre-sum, then we try to see if the count between left and right is greater than the threshold. So we have two situations. If left equals to 0, then let's say the count is C. If the left is 0, C just equal to the pre-sum. Let's say we just call this pre-sum to make it simple. Okay, so pre-sum right, and otherwise C should be equals to pre-sum right minus pre-sum left -1. And if C greater or equal to threshold, then we just return K. Okay, otherwise return -1. We delete this line here. Let's run. It seems correct, and let's submit. Okay, yeah. So the implementation will not be hard, and just this idea to use a TH to separate two situations, this is very hard to come up. But if you saw a similar problem before, I think you will just use this template to try to divide this problem to two sub-problems. And usually you need to balance those two situations to get the TH. Okay, so then this problem is solved. We'll see you next time. Thank you.